Today we'll have a look at acylation with acid anhydrides. Last week we had a look at acylation with acyl chlorides. Good news is with acid anhydrides there's no mechanism to do, we just have to know the equations. So if we have a look at this example with methylamine and ethanoic anhydride. So we'll draw the anhydride first, and it's like two carboxylic acids joined together with a loss of water, and hence the anhydride. So this is like two ethanoic acids joined together with a loss of water. So ethanoic, so we've got two carbons. And this is where we'd expect to put the OH of a carboxylic acid. Instead, we've got an O. So we've lost the H of H2O there. And here we've got the other. Ethanoic acid that's lost a OH in the middle of this. So this is our ethanoic anhydride. And we're reacting this with methylamine. So an amine is a substituted ammonia, and it's had a hydrogen substituted for a methyl group. So and with acyl chlorides we formed HCl as one of the products, but instead of hydrochloric acid here we form an carboxylic acid, whereas the acyl chloride on the bottom had a Cl which would bond with the H. Here if we choose a different color, then the H bonds with the bottom of the acid anhydride to form our carboxylic acid. So, and the rest of it joins together to form an amide, in this case an N-substituted amide. So if we just join the rest of this together, we've got the amide bond in the middle. Biologists might call this a peptide bond. In chemistry we call it an amide bond because it's formed from an amine. And we've got the carboxylic acid as well. So I'll just draw it underneath. So here, to name this is an N-substituted amide because we've got a hydrogen substituted on the nitrogen. So this is N-methyl. And then the amide part has two carbons, so that's ethan amide. And the carboxylic acid has two carbons, and so that's the ethanoic acid. This reaction is often preferred to an acyl chloride reaction because it's a lot easier to control than an acyl chloride reaction, and the product, the ethanoic acid, is less harmful than hydrochloric acid. Mm-hmm. And that's it. So methylamine and ethanoic acid methylamine and ethanoic anhydride give us N-methyl ethanamide and ethanoic acid.
Great. Yeah, nice to know that. And yeah, look forward to continuing with this series of reactions as well.